In this video, we'll talk about optimization, which is one of the main applications of the derivative, and talk about how to think about and solve problems of this type. What does optimization mean? Optimization is basically the process of trying to find the best or least or whatever optimal value you want for a given situation. You want to maximize profit, you want to minimize cost, you want to minimize waste of material, you want to find the largest of a certain object. This is what you're doing. You're doing optimization in that process. So it really results to finding some sort of maximum or minimum value once you quantify what you're trying to look for. And we've seen some of this previously. We've already talked about methods for finding max and min values of functions. So we had this before. Right? We came up with something like every continuous function on a closed interval attains its max and min value. And we also found strategies for how to find these points. What was this process? So basically our process here was we wanted to find all critical points of our function f. Remember, this is where f prime was 0 or f prime did not exist. We then wanted to evaluate f at those critical points and at the endpoints of our interval. Then we just picked the biggest for the maximum and the smallest for the minimum out of this list of values. And we knew how to do that. We could do that all the way out, and that wasn't a big deal. What's the difference with optimization problems? Well, the main difference here is that you're probably not going to be told the function and the interval at the outset. Part of the problem is working towards figuring out what is the function and what is the interval in which I'm optimizing this function. Basically, these will be word problems that you have to then decipher into what is the function, what is the interval, and then you can solve the calculus problem to get to an answer. See what an example of that looks like. Here's a problem we already know how to solve. Find the maximum value of the function f of x equals x times 10 minus x on the interval from 0 to 10. We know the interval, we know the function, we can just solve this using normal extreme value techniques. So we can write the function f as 10x minus x squared. I can then find the derivative, which is 10 minus 2x, and look for critical points, which would involve finding where this doesn't exist, it always exists, and where it's equal to 0. This gives me x equals 5 as a critical point, and then I have my two endpoints at 0 and 10. So I can now build my table of values, 0, 5, and 10. If I plug in 0 to my function f of x, I just get 0 because that's 0 out front. If I plug in 10, I also get 0 because of the 10 minus x. And if I plug in 5, I get 5 times 5, or 25. This is clearly the maximum. So to answer the problem, the maximum value of this function is 25. And that would be how you answer this problem. Now let's look at another similar problem. Find the maximum product of two numbers whose sum is 10. And here, we only really want to consider positive numbers, because if either number is negative, the product's going to be negative, so it doesn't actually affect our problem. So what do I want to do here? Well, if I call my two numbers x and y, what do I actually want to do? Well, I want to maximize the product x times y. But what else do I know? Well, I know these two numbers must sum to 10, so I know that x plus y equals 10. Okay, now this fact here is I can rewrite y as 10 minus x, and if I plug that in to this y, I'm now trying to maximize function f of x, which is x times 10 minus x. And what are valid numbers to plug in for x here? Well, x must be positive, so I have to have x bigger than 0. And I also know that y needs to be positive. So if y is bigger than 0, that means that 10 minus x is bigger than 0, or x is less than equal to 10. I'm going to maximize this function here on the interval from 0 to 10. Now that right there is exactly the problem we solved above. Find the maximum value of f of x equals x times 10 minus x in the interval from 0 to 10. We solved this already before. Therefore, I know this maximum product must be the same answer as above, which is 25. These problems here really have two parts. Part 1 is converting the word problem into a calculus problem, and then part 2 is actually solving the calculus problem behind it. The next video will go into a more detailed breakdown of this process and how you actually use it to solve optimization problems.